Okay, today we're going to look at the mean value theorem and also the average value theorem. If you remember back from when we were taking derivatives, we also had a mean value theorem and we also had an average value theorem. So we're going to look at that dealing with integrals as well. The mean value theorem is going to be first, if f is continuous on the closed interval from a to b, there exists a number c in the interval such that we get this fancy little equation down here. What I'm going to tell you what it is if we have a graph, something like that. Remember when we were doing the limits of summations, all right, we found the upper bounds and the lower bounds, and it was always either going to be, we find the area that was above it, or it's going to be too small or it's going to be too big. Well, what the average value theorem says is there's some value between A and B, where if we pick, maybe it's right here, this rectangle here, all right, is going to be the exact value of the area underneath this curve. All right, it's going to be the perfect rectangle for the value of the area underneath that curve. All right, and we'll do an example here to show you how we use that right here. All right, it says find the value of c guaranteed by the mean value theorem for the integral of the function over the indicated interval. So we have an f of x equal to 9 all over x cubed, and we're going to go from the interval from 1 to 3. All right, so we're going to use the mean value theorem. All right, and it says that if we take the integral from our upper and our lower bound, so from 1 to 3 of f of x, so 9 all over x cubed dx, all right, that should equal some value when we plug it into the function, some value of the function times b minus a, so times 3 minus 1 or 2. All right. So first off, let's try to basically we're solving for c. All right. So let's take this integral from 1 to 3. So let's move this up via 9x to negative 3. And we take the integral, we increase the power by 1, divide by the new power. Okay, sorry about that. I had to fix my smartboard real quick. All right, so we take the integral, we increase the power by 1, divide by the new power. So we would increase the power to be 9x to the negative 2 power, and we divide by the new power, which is negative 2. All right, and then we need to evaluate it from 3 to 1. All right, from 1 to 3. So we go the top minus the bottom. All right, so we're going to need, let's see, let's rewrite this over here. We're going to have 9 all over x squared. So I'm going to have, when I plug 3 in there, I'm going to have 9, I'm going to have negative 1/2 minus, let's see, minus the bottom. When we plug 1 in there, we'll have a negative 9/2. So plus a negative, we're going to have 8 all over 2, which is going to be 4. All right, so when we evaluated this integral here, we got 4. All right, so 4 equals f of c times 2. Well, let's bring our 2 over. So 2 equals f of c. All right, so what we need to do now, it says 2 equals f of c. We need to figure out what value, what c value will this function here equal 2. So we set, all we do is we set our function equal to 2, and we'll solve for our c. So we'll say 2 equals 9 all over x cubed. Well, let's solve this equation. We bring our x cubed over, divide by 2. So we'll have x cubed equals 9/2 and take the cube root, right? So x equals the cube root of 9/2. So at the value x equal to the cube root of 9/2, we're going to have a rectangle that's going to equal the area underneath the curve for the function 9 all over x cubed. Okay. Moving on to the average value of the function. If f is integral, if we can take the integral of f and it's on the closed interval, we can find the average value of a function. All right. And what it is, we're taking our upper bound minus our lower bound. All right, so 1 all over upper bound minus our lower bound times the integral from a to b of f of x. All right, this one much easier. Find the average value of 3x squared minus 2x on the interval from 1 to 4. So we're saying that it's going to be 1 all over 4 minus 1, so using the average value theorem, times the integral from 1 to 4 of 3x squared minus 2x. All right, and we take this integral, increase our power by 1, divide by the new power. We're going to get 1/3 times, let's see, the x cubed minus x squared. And we're going to evaluate this at 1 and 4. So when I plug 4 in there, 4 cubed is going to be 64. So I have 1/3 times 64 minus 16 minus 1 minus 1. So that cancels out. This becomes 0. All right, so let's see. 64 minus 16, we're going to have, what, 48? So we have 1/3 times 48. How many times is 3 going to 48? I'm right off the top of my head right now. I'm not sure. Let's see. 1, 18, 16 times. So our average value for that function is going to be 16. All right. How we could use the average volume theorem is kind of an interesting example. Here it says at different altitudes in the Earth's atmosphere, sound travels at different speeds. The speed of sound in meters per second can be modeled by this equation right here, dealing with certain altitudes here. These are certain altitudes here. Okay? And it's different for whatever altitude you have. It says where altitude is in kilometers. What is the average speed of the sound over the interval from 0 to 80? Well, we found out in our last video that if we took each of these integrals separately and then added them all together. So in this case, I'd take the integral from 0 to 11.5, and then I'd add it to this one, the integral from 11.5 to 22, and so forth all the way down the integral from 22 to 32. And added all of those together, all right, we'd get the integral of the entire function, s of x here. All right, so all we need to do is we need to take the integral of all these and evaluate all of them. All right, add them all up, and we'll get the integral. And what the mean value theorem then says is we're going to take, let's see, 1 all over 80 minus 0 times the integral of our function here, right, from 0 to 80 of s of x dx. All right, so I've done a little pre-work here. All right, I've taken all these integrals and I've added them all together. All right, and it takes a little bit of time, but it's not too bad. When we add all those together, we get our integral of s of x to equal 24,640. All right, so that's taken and then evaluating here and adding them all together. Okay. So what the average value theorem says is we can take, all right, so 1 all over 80 times our integral s of x from 0 to 180, or it's from 0 to 80, sorry. So that's going to equal 24,640. And we divide by 80, we're going to get an average velocity of 300 meters per second. All right. So there's one way we can use the average value theorem with integrals. I hope this helps. See you in class tomorrow.